Hi guys, in this video I explain binary search. I first declare a prototype named binary search that expects an array of integers, the size of the array, and a target value. If the target value is found in the array, it returns the index where in the array the target value is located. If the target value is not found in the array, it returns -1. I also declare a prototype named print. This outputs the integer array to the console. I implement the print prototype below the main. This outputs an opening square bracket followed by the first element of the array. And then for all subsequent elements starting at index 1, it outputs a comma and the element. And finally, it outputs a closing square bracket. Next, let's implement the binary search prototype. Now, before we can implement this function, we have to understand how binary search works. Now, binary search always expects a sorted array. And I have a sample array here with the values 23, 31, 45, 67, and 91. It has the indices from 0 till 4, and the length of the array is 5. Now, binary search defines a search space, and initially the search space is the entire array. It takes the middle value of the search space, and that gives the index of 2. This is where the middle of the search space is. It accesses the element at that index and now compares it to the target. Because it is a sorted array, it knows if the target is larger, it navigates to the right. If the target is smaller than the middle value, it navigates to the left. And then it repeats the same process. Now, if it navigates to the left, for example, this is the search space. And so now it takes the middle value again. In this case would be 1. It checks the value and then either goes left or right from there. Now here it wouldn't be able to go right. So if it is larger, it checked already 45, it checked now 33, there's nothing in between, it would return -1. But the concept is that it always determines the middle value of the search space, compares it to the target element, and then navigates right or left, depending if target is larger or smaller, and then repeat the same process. So we need to define the search space with 2 integers. I name them left, initialized to 0, and right, initialized to the size. This initially defines the entire array, starting at index 0 and setting the boundary 5 as the length of the array. Now I want to search at least once, so I use a do loop. And here I determine the middle index of the search space. This is determined by left plus right minus left divided by 2. This formula gives me the middle index. Let's take an example. Let's say we have 0 and 5 initially. These are the values I initialized left and right to. Now, if this is the search space, it should give me 2 as a middle value. So this gives me 0 plus 5 minus 0, which is 5. 5 divided by 2, which is 2 for integer division. And then 2 plus 0 is 2. So here I get the middle value. Now I want to compare the value at this index to the target value. So I do array at mid equal target. If this is a match, I found the target value in the array and I return the index, which is mid. If it's not a match, I check if the target value is larger than the middle value. Or in other words, if the value at mid is smaller than the target. In that case, I have to go right. Because if target is larger and I have a sorted array, I know it has to be on the right side. Now, if this was my original search space and I want to go right, the new search space should be 3 and 4. So starting at 3, which includes the element here, it would be mid plus 1. So I update left to mid plus 1. Now the last option is basically the target value is smaller, so I have to go left, because if I compared equal, so target value is not equal, it is not larger, the only option left is that it is smaller. And when it is smaller, the left stays the same, but I have to update the right. And since the right is always excluded, I can simply assign the middle value to it. So I do right equals mid. Now after I updated left or right, I want to do the same process. So I continue the loop and compute the middle index based on the two left and right values. I want to do this as long as I have any elements left to check. And this I can use the condition as long as left is smaller than right. If this is smaller, so for example, if right is 1 and left is 0, I still have 0 left. 1 is excluded, right I always exclude, so I have 1 element left. If they are the same, so if left equals right, they are 0, I have 0 elements left, the first index is 0, there's nothing left for me to search, so this condition would end the loop. If it ended, I just return -1. It did not find anything. Now let's go ahead to the main and declare an array with these values. I first define the size with 5, then an array of the size initialized to these sample values, and then I have a target value that I want to search for, let's say 91. I declare an variable named index and I initialize it to the return value of the index function. I pass an array, size, and target. And then I output the index to the console. Now let's run this. And this should now first look 45, because it's index 2, that's the middle index. 91 is larger, so it would look here 67 on this side and then find 91. Now we can also here output the middle value, so we see what it actually checks. So when I run this again, first it's the entire array search space. It determines index 2. Index 2 is 45. 91 is larger than 45, so the new search space is basically 3 and 4. Then the middle value will be 91 and it finds a match. 91 matches the target value, so it returns 4. Let's do one more example. Let's say we do 31. So 31, it determines to 41. 31 is smaller than 45, so it goes to the left. Here, the middle value, it determines 1 with integer division. 1 is 31, 31 is a match, and it returns 31. Now if I would make this 35, so 35 is a value between 31 and 45, and it does not exist. If I run this, it first checks index 2, 45, so it has to go left. Here it checks 31. Now it has to go right, because 35 is larger than 31, but there's no search space left, so it ends the loop and returns -1. Now binary search is very efficient. With each comparison, we remove half of the array, half of the values that we have to check. So if we have 1,000,000 values and we do one comparison in the middle and we know we have to go left or right, we just removed 500,000 values with a single comparison. Now if we did this with linear search, we would have to compare all 500,000 values. And then with the next step, it cuts out half again. So if we removed 500,000. Now we search the other 500,000. We do another comparison. We removed another 250,000, because we always take the middle value and then go left or right. And left or right, we can ignore the other half. I hope you enjoyed this video. Thank you for watching.